Hi and welcome to the channel. Now I've had a few requests, one being how to test a transistor. There is some videos about this obviously, and also how to do some soldering. Now I did do a little soldering video ages ago now, didn't really get many hits, and everyone's got their own unique way maybe of doing it, to a certain extent anyway, of doing soldering, unsoldering, using soldering gun with a built-in sucker, using a solder sucker, using braid, all that kind of stuff, and soldering techniques. So I don't think I'll bother going down that route, but what I may do is actually make a couple of these little boards up at some stage. These are little kits, and these are a great way of starting soldering really. They're quite tiny, some of these, and got very small joints. So once you master something like this, soldering it and unsoldering, once you've made it, you can test it out and then start unsoldering a few parts. It's going to give you some good groundwork for doing old vintage stuff, because old vintage stuff's got some big joints on it, shall we say. When you compare these little joints, these are very tiny, and vintage stuff has got some big joints. And once you master this, you're probably easily going to master taking vintage stuff apart. So it's a place to start, and I may do one or two videos in the future. Now, people have asked me, a few people actually, about doing a video about testing transistors, and there is quite a few videos about on eBay, I think of eBay mad, on YouTube of testing transistors, quite a few good ones there as well. But I thought what I'd do is try and do a very, very basic one here without going into too much detail. Not that I'm any expert on transistors, don't get me wrong, I'm not an expert on anything, let's get that straight from the start. But I thought, if I'm not an expert, sometimes you go to these channels and that, and they're mastered it, they're quite high up. It's like when you go and learn something sometimes from someone who's a master. They don't quite go back to the basic roots maybe, and kind of skips bits and thinks, well, you should know that, or he knows it, so you kind of should know it, kind of thing, and don't really go back to the bare bones, shall we say. So I'm going to try and do a Blue Peter approach. This Blue Peter little program in England where they make stuff out of cardboard boxes. I'm not going to do any of that, but hopefully you may be able to pick up if you're a complete novice. This is not for an expert or anything like that. But I mean, admittedly, you can get one. We're going to do it with a multimeter, by the way. This is with a multimeter, a digital multimeter at that. We're going to use a digital multimeter. I may do another video with an old analog multimeter at some stage, because it is different. But we're going to use a digital one for today, and we're going to put it on the diode mode. So make sure you put it on the diode mode. But before we start that, if you want to test transistors, they're working on that. This is a great little device. Something like this isn't expensive, about £25. But you can get a multimeter for about £6–7, something like that. And I think that's about all this costs. But I'm going to use a couple of multimeters here just to show you that there is a difference sometimes in the readings, and that's probably due to the battery or the way it's set up, etc. inside. There's going to be some slight differences in the readings, but you're going to get a gist and an idea if the transistor's working or it's not working, not doing what it's supposed to do or not doing what it's supposed to do. And for today's video, I'm going to be talking about exclusively about these little oops, I'm not the camera flying. These little transistors here, these little bipolar junction transistors. They're going to be NPN or PNP. We're going to come to all that later. And this is in a package. They call this a way these are made and shown as in a package. These are package type transistors, and these are TO92 packages. Of course, there's vast amounts of transistors. Take no notice of all the wires I've got connected to this, but this is another type of transistor, but we're not going to be testing anything like that today. Like I say, I'm going to concentrate and talk about these little transistors that you are going to find in amplifiers and receivers. These go all the way up to nearly towards the power transistors, from the very, very start in the preamp section all the way up. And I just wanted to say, maybe a bit of a long video as well, that when you're testing these, you're just testing if they're working. You're probably not going to test if they're intermittent. They're making noises where you get some noisy transistors. This is not going to tell you that, but it's just going to tell you if it's working, and give you an idea how to test a transistor. I mean, you can test, I'm going back to this one very quickly, you can test transistors like this as well using this method, but I'm going to go to these because I'm going to also show you and tell you how you find a base collector and emitter on these little small packages, which I didn't have much joy with these bigger packages in doing that, but it seems to work on all the transistors and what I've been reading on the internet on these little transistors. So what we're going to do, got my meter set up here. It's a digital meter, like I say, these are not expensive. Make sure you've got it on the diode mode. You've got the positive lead in the positive connection and the negative or the common on this meter in the common or negative, black to black, red to red. Very important you get it that way around, or it's going to give you the wrong readings. So that's a good start. Make sure you've got your meter set up properly on diode and you've got them leads in the right way round. Okay, so let's have a look at the different types of transistors, the PNP and the NPN. Right, I'm going to try and explain these. Like I said, I'm going to try and keep it as simple as possible, very, very simple, so you can measure them. It's all about just measuring them, not really not knowing too much what's happening, and getting bogged down with, for instance, current going in one direction and electrons going in the other way, kind of thing. So we're not going to talk anything about that. We're not going to get it too complicated. We're going to keep this very, very basic. And we've got two types: an NPN, sorry, a PNP. Let's get it right, Mick. You're supposed to be teaching. I'm not teaching. I'm just, giving you hopefully some hints here, some directions or whatever. Okay, so this is a PNP and this is an NPN. So for the PNP, we're going to keep these transistors. Some people turn this round, this transistor, which when it's the other way round, they swing that and put the meter up here and the collector down here. I thought it may just complicate a few things, so we're going to look at it as is, like this, so we keep it nice and simple. So we've got the PNP, and basically this is positive, negative, positive, positive, negative, positive. If you just remember that, and this is negative, positive, negative. If you just remember that. So what we got here is PNP. So we kind of start from, the base is always in the middle. That's maybe the best way of explaining this. The base is always in the middle. So whatever the middle of these three letters are, that is the base. So in this case is N. So the base is negative, we're going to call that. And for NPN, the middle one is P. So the base is going to be P. So if we get it that way, so we know N, negative, is here. So that's negative. So it's positive, positive. So it's PNP for this particular transistor. And if we go over here, it's NPN. So they're the two types of transistor in this little TO92 package. Okay, we've got another picture here now. They're getting a bit complicated now, Mick, but don't worry too much. I'm going to really go down and kind of give this definition, very, very basic here, of which way you should be connecting your meter to get a reading and which way won't give a reading. And I've got some arrows here pointing in different directions, but what it is, this transistor is a PNP, it's a BC558 in this particular instance, and this is what's going on inside that circle, really, just kind of showing you what's going on inside that circle. And we've got here a diode here, which only lets current flow in one direction, and it's the direction it's pointing in, the little arrow is pointing in, so that's the direction it's going to let the current flow through. Maybe if you call it water, and this is a gate, and it only lets water through in this direction. If it comes through that way, the gate stops it coming through. So it's pretty much the same as the current there. So we're going to go from positive to negative. It's going to flow in that direction. So on the PNP, don't forget, it's positive, negative for the base, and positive. We still don't know what the collector emitter is at the moment, even though I've labelled it up. But like I say, PNP, the middle one is the base. So the base is negative. So we put our meter on negative, our common, or negative on the meter, the black lead on the negative here, on the black little dot here on the base. And if we put a positive, our meter on the positive, we will get a reading. If we've done it the other way around, we won't get a reading because nothing's flowing, everything's going in the wrong direction. It won't let us through. Imagine this is a crowd of people running down towards you, and it's just you and about 1 million people. You're not going to get through. So it's pretty much like that. If you put it the wrong way around, you're not going to get through. So nothing's going to happen. You're going to get no reading. So to get a reading, we've got to put a positive here and a negative here. And the same down the bottom here. To get a reading, we've got to put a positive here and a negative on the base. So the negative, don't forget in the middle, PNP. Now we can't put our meter reading at the top, say a positive here and a negative here. We'll get no reading because there's no way through. Even though we're going in this direction, as soon as we get there, we've got a lot of people coming in the other direction. We can't get past. So we're not going to get a reading if we put our meter here and here. If we put the positive here and the negative here, there'll be no reading. If we put the negative here and the positive here, we're still going to get no reading. So out of this particular transistor, we're only ever going to get two readings. That's when we put a positive here and a negative here, we'll get a reading. We put a positive here and a negative here, we're going to get a reading. There's no other situation to get a reading. If there is, then there is something wrong with our transistor. And when I say a reading, I mean it's going to change. It's not going to stay where it is. If we put our meter here and here, positive here, negative here, and we get no reading, we know this has gone open circuit. Something's gone wrong. We must get a reading if we get it the right way round. So we're going to come to that. We're going to test the transistor in a minute and see which one we got. It's a working transistor. I'm not going to tell you which one it is at the moment, but we're going to suss out that it's working, and we're going to find out which one it is by using a digital meter. Just quickly going to go on now to a NPN where it's the other way around. We've got negative, positive, negative. Don't forget the P in the middle is the base. So it's positive. The collector and emitter, even though they don't know which one's what yet, is going to be the negative. So we put our negative here and our positive here. We're going to get a reading because we're going from positive to negative. Don't forget, that's the flow we're going where the arrows are pointing. So we're going to get positive here, negative here. We're going to get a flow. We're going to get a reading. Put our positive here and negative here. We're going to get a reading because we've got that flow. But if we put our positive here, negative here, we can't get a reading because the arrow's going the wrong way round. It's not letting us through. So no reading. Same if we put our positive here, negative here, we're going to get no reading. And again, if we put our positive here, negative here, no reading because we can't get through, and vice versa. The other way round, we still can't get through. So we're just looking for two readings again. If we put a negative here and positive here, we're going to get a reading. And negative here and our positive here, we're going to get a reading. So that's the two versions of transistors, PNP and NPN. This is the package type that we've got. At the moment, this is a BC548. I'm going to be testing two, a 548, which is NPN. Oh, my light's gone out there, so hopefully I can get that to come back on. I'm not too sure what's happened with that. I think I've bought myself a dodgy light. It seems to have gone out. So we'll sort that out. You can still see what's happening anyway, I think, with this. I'll turn the light on for the next little bit. Okay, this is a TO92 package. This is the flat side. So on my board, the flat side will be facing you. I'll take a picture of that on the screen now so you can see how this is on that board, and now it's kind of wide up in a minute as well. But that's the flat side. It's kind of got an half moon shape, shall we say. So that's the flat side. Normally got the writing on it as well. So in this particular case, we know which pins are what. Pin 1 is collector, 2 is base, and 3 is emitter. But you may not know that yourself, but there is a way of finding that out as you do the tests. So what we're going to do, we're going to do some testing now. Now, you may think, oh, I might as well forget all that. Mick, just show me how to test it, and I can suss it out myself. And that's probably the case, to be honest with you. That first few minutes, etc. Maybe not what you need to know exactly, but just give you a rundown what's happening. Now, I'm not going to tell you what transistor this is. We're going to work it out, but I've got it facing flat down. So the moon part of it is hitting the board, and the flat part of it's facing you, and the flat part is normally where the writing is on this particular transistor. Hopefully you can see that. So on the board, I've got it like that. So if I show you a picture of the board, and showing you that picture, I just want you to take note of these three connections here. 1, 2, 3. These three here. This one here. 1, 2, and 3. Move that board a little bit away from them leads. 1, 2, and 3. Just to show you that board. Forget these two here. So I'm just going to show you a picture of them, and you can see where it's connected up to this transistor. This here is connected to this very first pin, pin 1. This middle one is connected to the center pin, which is pin 2, and this pin, this connection here is connected up. You can see it through that bit of a pen mark I've made, goes to the very outer pin, which is pin 3. Got our meter, don't forget, get this set up properly, red to red, black to black, on the diode mode. And we're going to do some readings. We're going to suss out what transistor we've got here out of these two. We've got an NPN and a PNP, so we're going to work it out, which one of the two. I've only got two, which one of the two. And this transistor works correctly, and we're going to do a few experiments later on where it doesn't work correctly to give you an idea what happens if it doesn't work correctly. So let's do it working correctly first of all. So we're just going to randomly, really, put our, remember where they were, but just put our meter pins in different places. Doesn't matter which way. So we're going to start with, say, the negative here in the middle one. Hopefully you can see that. So I'll take that out of the way. Negative's in the middle. I'm going to put the positive on the outer one. There you go. And we look at our meter and it still says 1. We've got no reading. We're expecting a reading there. We're expecting that 1 to change. We're expecting a reading. Just make sure they've got good contact. Just going to tap them slightly. Nothing's happened in a meter. So that there is not correct. I wouldn't say it's not a fault, but you may think I've got a fault here, but we haven't got a fault because we're waiting for 2 readings to happen. For this transistor to be working correctly, we're waiting for 2 readings. Out of all this combination, we're waiting for 2 of them to be correct. Now, if only one of them is correct, obviously we've got an open circuit. If none of them springs into life, then it's completely gone open circuit, all over the place kind of thing, base to emitter, emitter to collector, all that kind of stuff. But for the time being, we're just going to go like it. We're going to twiddle about until we get it to do some reading. So there's no reading. So we're going to just leave that in the middle at the moment. We're just going to move this positive here to the other side, see if we get a reading. and we've got no reading there at all. So we give that a go. That's nothing. So now just remember where you've been. So now just take this negative out and we're going to put it there. And we still got no reading. Just before I say also, I'm doing this on this board so you can see hopefully a bit easier, but you may be doing this with a transistor like this in your hand, trying to put the leads on one leg and leads on the other. And maybe just an idea is to get a bit of blue tack or something, like a bit of sellotape or something, and sellotape this down to your desk or something, or a bit of blue tack in your desk, or double sticky tape or something, just to hold that still so you can put the leads on the transistor easy enough. Otherwise it just becomes a bit awkward and your fingers kind of get in the way. It needs a proper contact, don't forget. Okay, so that's what we got so far. No readings yet, so now we're going to move this positive to the middle now, because we never had it in there at the moment. So we stick it in the middle, and as soon as we do that, we've got a reading here of 732. Hopefully you can read that, 732. So we've got a reading. So we know that works. So that's one. We want one more reading. So what we're going to do, we're going to move this pin across, and we're going to move it to the other side, and we're going to let go. And as soon as we do that, we've got another reading here, 737. So we've got our two readings we require. So just from now, we know that this here is positive. The positive needs to be here of our meter. So I'm going to take it out for the time being, and we're going to get a little connection, little thing here for myself, just to show you really that that's the positive. So we're just going to screw that on there a couple of turns just to hold it on there. So that's positive. We know this is negative, so we're going to put the negative on there. And we know when we had the meter a minute ago with a positive there and the negative here, give the reading. So this is another negative here. So we take the meter completely out and we put our negative on there. So now we've got negative, positive, negative. So we've got NPN. So NPN, if we have a look at our charts, there's only one NPN we've got, and it's this particular transistor here, which is the BC548. So I know on that board I've got a BC548. It's working correctly, and if we look at the pinouts here, we've got negative, negative, positive, positive, negative, negative. So we got the three positions the pins are in, but all we know for certain, this is the base. This red one is the base. That's for certain. We don't know at the moment which is collector and emitter. So what we're going to do, we're going to find that out now. So for the emitter, it's going to give a slightly higher reading. It's going to give a slightly higher reading for the emitter. So what we're going to do, we're going to put our meter on there, and we're going to put the other on here, and we're going to take a note of that reading. Just make sure you get a good contact here. And the meter seems to make, because I put them, you just have to bear with me. I've got my fingers on there. You know why? Because I've got these, let's just screw them in a bit more. They're not making the lead go down long enough to make a proper connection. So if I screw them down a bit more, just bear with us, we're going to get a bit better connection. It's all about connection. You need a good connection to get a good reading. So we're going to leave it loose here. That should be all right now. The weight of them should be enough. There you go. 737 there. So we're going to swap it over to this side and see what the reading is. And the reading is 732. So it's lower this side than it is that side. So this side's higher. So we know the higher is the emitter. So that's the emitter, that's the base, and that's the collector. And that seems to work with all the transistors I've got here. From what I'm reading on the internet, these TO92 packages, that seems to be the correct method of finding what the base, collector and emitter is. So there you found it out. So we're just going to go back once more, and we're going to check again. We're going to put this meter here. You can see there, we've done it before, but we can see that there's no reading. So that transistor gives us two readings, and we've deduced that it's NPN and it's working correctly. So that is how to test that particular transistor. We're going to do the 558 now. Okay, just before I go on, this is the other transistor, the 558, but just before I do that, it's not always convenient that the base is in the middle. I made this video as simple as possible because the base is in the middle there, but your base may be on either end. It may be on pin 3 here, or it may be on pin 1 there. It's not always in the middle. It's not always that convenient, but you will find that out by testing it. You know, as long as you get them two readings, as soon as you've got the two readings, you'll be able to define which is NPN or PNP. But if you don't get two readings, you only get one reading, you're not going to be able to find that out. You do need two readings. And when I say a reading, a measurement here, it mustn't be a short circuit. We're going to come to that in a minute. Some short circuit and open circuit ones, you'll see the difference there. But you will get a reading, and that reading will change depending on meter as well. It'll be slightly different. I'm going to bring another meter in shortly and show you that as well. But for the time being, I've got this 558 now, so we're going to determine which is what pin here. So I'm just going to put these randomly in really, but remembering where they were, as we'll be doing the same ones over and over again otherwise. So I put negative to pin 1, positive to pin 3 there, as you can see. And we're just going to start swapping them around. I'll move this negative over. Oh, and all of a sudden I'm getting a reading of 734. So we know this is negative here, so just remember that negative. So we're just going to swap this pin over here to this side, and by chance there we've got a 728. Now we're going to go through the other combinations to make sure that none of them's wrong, none of them shorted out. So let's just do that quickly, going through a different few combinations, and we're back to where we were, where we know this is negative and this is positive. So what we're going to do, just to make sure we know that, is just put them in there here. This is something you'd have to write down or remember yourself, so it's just, you're probably not going to have a little board like this, but we know that's negative and it's giving a reading, so we've got that negative there. Just double check that. There you go on the meter. We know this positive here, so we're going to get another little red one and put it here. And now it's whether this is a negative, because this could be the base here. This red one could be the base if it's a different transistor. We could get another negative here. So we'll just try that. We'll do a positive here and a negative here, and there's no reading. So this here could, like I say, could either be a negative or a positive. So we're going to swap it over to make it a positive, and we're going to put the meter there, and it's no reading there. So it's there, no reading. So we're going to keep going until we actually make that one or the other. So there you go. We've got a reading now where this is on pin 2, this is on pin 3, and we're getting a reading. We're just going to swap it over, and we're getting no reading. Back to where it was, and there is a reading. So it's a combination of any 2 from 3, which is 6 ways round. You could measure this in 6 ways. These leads go in 6 different directions, if you know what I mean. So we just go back to that, and we go back over to here. Getting a bit complicated, I know, but so we know this is positive here as well. So we can take these pins out and put that there as positive. So we know now this transistor here is PNP for this transistor here. We're just going to do all the testing now just to make sure there's no shorts in this transistor. Something I didn't do with the other one, but just to give an idea, there's no shorts. This is the way it's reading. Then we're just going to check it doesn't read any other way now, the wrong way. So we're going to put the pins in the opposite places they should do. So we're going to put a pin positive there, and this should be negative if I was using this correctly. But as you can see, it's a positive. We know it's a positive, but we're putting the meter in there, and it should give no reading. We're going to go the other way around as well. There should be no reading there. Just show you there, it's pins 1 and 3 with the negative here, 1 and 3 again with a negative over the other side in pin 3. No reading. We're going to go here positive in the middle to this pin here, to pin 3, no reading, to pin 1, no reading. So we should cover all 6 combinations, and only 2 of them combinations you should get a reading. And the combination, the correct combination is like so, there and there. Any other combinations would be wrong. Don't forget there's 6 combinations. We've got 6 pairs. These can go around 6 different ways. So just remember that. Maybe I'll put a little chart up on the screen there of all 6 combinations that these this meter could go in, to give you an idea what to check. Okay, so now we know it's an NPN. Oh, sorry, a PNP, P positive, negative, positive, PNP. We're going to bring our little chart in there, and that confirms it. It's a PNP. We're going to find out which is the emitter. Don't forget the emitter is the highest one. We're looking for pin 3 here. The emitter should be pin 3, which is over here. So we're going to put our meters in here and here, and we're going to check that reading at 728. So we're looking for an higher reading if it's correct over here. 728, and we've got 734. So we've got an higher reading here. So we know this is collector, base, and the emitter with the I reading is over this side here. So that's that transistor. So what I'm going to do now is show you where some shorts and open circuits come up. We're going to go through them 6 combinations and make sure we're getting the correct readings. Okay, now what I thought I'd do is actually I put that chart up there on the screen, just to explain it a little bit more here, to actually verify. And this transistor still works fine. Just want to verify how we're going to test this to make sure you get the connect way round of these pins. The 6 combinations are written down here, where P stands for positive. This is where we're going to put our positive probe, and N stands for negative. This is where we're going to put our negative probe. So 1 and 2 comes up again as 2 and 1. But as you can see, the probes get turned round. Where the positive was 1 before, when it comes down here, the positive is going to be pin, and it's going to be 2, pin 2, and the negative is going to be 1. So the positive was 1 there, but when we come down here, the positive is pin 2 and the negative now pin 1. We're going to swap them over. So we're going to do that test here with this working transistor, just so you can see the 6 combinations we can get here to test if this transistor is correctly working. We know it's working because we've done the test. We know what base collector emitter is, all that kind of stuff. But and we know it's a PNP. But we're just going to show you. Well, I'm just going to show you the 6 combinations. So we're going to get the positive here. We're going to go start at the top. We're going to do positive here and negative there, and we've got a reading there. Hopefully you can see 728. So we're going to tick that. We've got a nice reading. We can write it down if you want to. 728. That's passed. So what we're going to do now is pins 1 and 3, positive in pin 1 and the negative in pin 3. So we put the negative over here, and as you can see, we've got no reading there. So do that as no reading. Now we're going to come down. We're going to do the positive in pin 2. So we're going to swap that over to pin 2, and the negative in pin 1, like so. And we're getting no reading. So we're going to put no reading here. There, no reading. We're going to come down again. We've got positive in pin 2 again, so where it is, but the negative in pin 3. So hopefully we can swap that so we've got it right there, like so. So hopefully you can see that positive in pin 2, negative in pin 3. Look at a meter, no reading. So we're going to put a line through that, no reading. Now we're going to have our positive in pin 3. So we move that over there, and we're going to have our negative in pin 1. So we put that there, like so. And then again we've got no reading, so we'll put a nice line through there. So our last one's positive in 3 and a negative in 2, so let's fill out. But hopefully these leads do get twiddled up, but hopefully you can see that okay on camera what we've got there. The 2 leads, you can probably see that, I would have thought, where they're going. And we're getting a reading there, and in this particular case we've got 735, and we'll put a tick there. So don't forget, we need 2 readings to know the transistor's working. We've got the 2 readings we require, so this transistor is working correctly. So now we're going to test a faulty transistor. Okay, so what we got here is a faulty transistor, and it's a PNP transistor. It's a BC558, but I've got a faulty one here. So hopefully I'm going to show you how we find out this is a faulty transistor. It doesn't just give 2 readings in this particular case, which we require to find out if it's PNP or NPN, and it's working correctly, don't forget. So this is pin 1, 2 and 3. 1, 2, 3. And this is where we're going to put the positive throughout the calculation. This is where we're going to put the negative of our meter through the calculations. And there's 6 combinations that these can go round in, vice versa, etc. I mean, the light seems to have gone out just at the wrong time, so I shall put that back on there. And hopefully that's going to stay on. If I give it 2 beeps, that should stay on for 30 minutes, hopefully. Okay, so, right, okay, so let's do the experiment. We're going to start off, and I've already done one, but we're going to do it, like I say, I already wrote it down because the camera decided to turn itself off. So the very first one, positive on pin 1, negative on pin 2 as here, and that's giving 727 last time it read, but it's giving 728, may just be, there you go, it does fluctuate a little bit with a little bit more contact. So we've written that down, we've got one reading there. So now we want the positive on pin 1 and the negative on pin 3. So we're just going to move the negative over to pin 3, and we're going to take a reading there, and that's giving 727. So we're going to write that down. And we're going to notice straight away that's a little bit coincidental. It's exactly the same reading as pins 1 and 2. We've got 1 and 3, but we're going to put that in the bank for the time being, shall we say. So now we're going to put the positive on pin 2. So let's take this out. Positive on pin 2, which is the middle, and the negative on pin 1 there. So that's like so, and we're getting no reading now, so we can put a line through that, no reading, so that's great. So we're going to leave the positive on pin 2, and we're going to put the negative on pin 3, so let's just swap them over like so. so it's like so. And don't forget, this is on diode mode, the meter, and we're getting a reading here of 001. So nowhere near the 600-700s we're expecting, that kind of thing. 001, so that pretty much is a dead short. So that's a dead short. So we'll write it down 001, but it's probably 0 to be honest with you. But we'll put it down as 001 or 0 between them two connections there. That looks like a dead short, but now all of a sudden you can see what's happened. We've got 3 readings, 1, 2, 3. This is a dead short, but so we know this transistor, something's wrong here, and it looks likely, or very likely, and it is a short between pins 2 and 3. But we're going to confirm that because we've got a couple of more tests to do still. So we're going to put the positive now in pin 3, and we're going to put the negative in pin 1, and we're going to have a look on the meter, and we're getting no reading there at all, so that's blank. And we're going to do the very last reading, the positive in 3 and the negative in pin 2. We're going to swap them over, and again there we go, we've got 001, which we'll call a dead short. 001, which is 0 really, so we've got a dead short. So in this particular transistor we've got 2 readings here exactly the same, and it looks like we've got a short between pins 2 and 3 and 3 and 2, which is the same pins between 2 and 3 and 3 and 2, no matter which way round. We've got a dead short, so pins 2 and 3 are shorted out, and this will be the case. So these are actually connected together, and that's why we're getting the same reading, because 2 and 3 are shorted out. It's a dead short, so we know that's why we're getting exactly the same readings, because while we're putting the meters on 1 and 2, we're basically putting it on 1 and 3 at the same time, because they're connected up together and they're a dead short. But the giveaway here also is we've got 4 readings. We've only supposed to get 2, we've got 4. So that transistor is no good, and we know we've got a short between 2 and 3, or 3 and 2, whichever way around you want to call it. Them pins are shorted out. So that transistor is no good. So we're going to test one more transistor now. Okay, hopefully you're still with me. Now we've got another fault with this transistor. It's still a PNP, positive, negative, positive. So we're going to do our tests here, as we should do. This is the positive, where the positive cable is going to go, and this is where the negative cable is going to go. And don't forget, that is 6 possible combinations that these can go in. So we're going to put our positive on pin 1, like so. Get it in there. My hands are a little bit cold all of a sudden. And on pin 2, the negative, and we're going to take the note of the reading, which is nothing. So that's nothing. So we'll put a line through. That's great. Don't forget, we need 2 readings. Any less or any more, then something's wrong, and we can suss out what it is by what we get. So now we've got the positive in pin 1 and the negative in pin 3. Don't forget, this is positive, negative, as labelled up there. Again, we're getting no readings, so we'll put our little line through that. So now we're going to move the positive to pin 2, like so, and we're going to move the negative to pin 1, like so, and we're going to take a note of that reading, and that's nothing as well, so we'll make a note of that. And now we're going to leave the positive in pin 2, but we're going to put the negative in pin 3, so we're going to sling it over here, or put it over here, and there you go. We're getting no reading there at all, neither. So we're banking on the last 2 here for some readings. So now we've got the positive in pin 3 and the negative in pin 1. And we're getting no reading there whatsoever. So we'll put a line through that. So we're not doing too well here. It looks like something's gone open circuit because we're not getting a reading. So there's no circuit being connected, so open circuit. So we're going to leave that positive in 3 and we're going to put this in 2. So positive in 3, negative in 2, and we're getting a reading of 736. So we know somewhere along the line we should be getting 2 readings. We're only getting 1, so this transistor's gone open circuit. One of the connections is opened up and is not making a connection. We don't know which one, because not unless we look this transistor up. If we looked up the number of it, etc., we're going to find out which is base collector emitter, and we're going to find out which is if it's PNP, should I say. We're going to find out also if it's PNP or NPN. In this case, we know it's PNP because that's the one I'm using, but you may not know that. If you've got a transistor you can't get to, or something like that, or you can't see the number, then you don't know what it is, because you've only got 1 reading. There's no way of knowing, there's no way of comparing anything else. You've just got 1 reading. You know the negatives here and the positives there. Negative in pin 2, positive in pin 3, but you don't know if there's another negative or another positive, so you can't tell if it's PNP or NPN, because you're not getting them readings. Like I say, if you've got a marking, if it's marked up the transistor, then go online or something like that, type in the number and you'll find out if it's NPN or PNP. You'll get the pin outs of that transistor and you'll be able to work out which pins are working here and which pins ain't, which should be working, and you can find out where the open circuit's gone. So there you go, that is an open circuit transistor. Okay, now we're going to test a transistor that's on a circuit board here. Now you're going to have to trust me a little bit on here because I can't zoom in with the camera really. You're not, my hands are going to be in the way because the connections are so small and that, but hopefully I'm going to try and get you so you can see them. But yeah, so basically if I just get this probe here and show you, if I get a bit close, hopefully you can see it. I'm going to be testing, I know where the transistor is, it's just here. It's these 3 pins here. 3, 2, 1 I'm going to go. 3, 2, 1. It's them 3 pins there the transistor is. So what I've done is I've marked them 3 pins up as they are, and hopefully you can see this. 1, 2, 3, that's how it is on the board. And I'll be doing that test in there as we've done before. Positive lead here, negative lead there, and what pins they go to, and we're going to mark down what it says. But before I do that, it's not always easy. You're going to get a short. You're probably going to find a short quite nice and easy. It's not always easy to know in circuit, you know, to get the actual 100% correct. It's best to take it out of circuit to desolder it, but you're going to get a general idea, and as you do it more and more and get used to the circuits, it's always best to look at the circuit diagram, give you an idea if you've got any inductors going across a couple of pins or any very low value resistors, which is quite rare, but it can happen, I suppose. Just for instance, I'm just going to, it's not this particular circuit diagram, but just give you an idea of what I mean if I do this the right way up. You can have some components around, you can have a couple of resistors, these are I resistors. So this is only a 68 ohm resistor here, but it actually goes back through a 4.7 anyway. But just to give you an idea, a little capacitor here, I mean this capacitor could have went short circuit, and when you're doing a reading between say collector and base here, that could have went short circuit. You could think it's a transistor, and it's actually that little capacitor's gone short circuit. Just to give you an idea that it's not always 100% correct, but it may give you some good idea. And if you look at the circuit, the more you get used to it, you're going to have an idea what else it could be. And anyway, if you expect this to go short circuit, you're probably going to take it out and test it again on your meter, etc., out of circuit anyway. But or open circuit, even that you're probably going to take out and test it on your meter for definitely. But it gives you some kind of idea, I think, in circuit. But it's not always 100%. What I'm trying to say is not 100%, but it gives you some ideas. So anyway, we're going to test this this transistor here. You're going to have to trust me where I'm putting my pins. With this, and we're going to make our notes down here on the side, and this is the pins 1, 2 and 3, and that's how I'm going to be testing this. So anyway, let's give it a go and see how this actually reads. Hopefully you can see my meter all right, you can see everything all right, and my light's not going to cut out again. I bought a cheap, not a cheap light, a light, and it seems to make its mind up when it's going to turn itself on and off. Okay, so we've got the positive lead here on pin 1 and the negative on pin 2, so we're going to do that here. You may be able to see this, I don't know, but anyway, we're getting a reading now. We come straight in and we got 735. So we're going to write that down. It's just right here, 735. So we've got a 735 reading there, but and already we know that the positive, this is P. We know pin 1 is positive because we've got a positive there. We've got to put a meter positive there. So pin 1's positive and pin 2 was negative. So we've got 2 PN we got at the moment. We've got the PN, we've got the reading there to tell us that. So what we're going to do now is do the next, we're going to put the positive on pin 1 and the negative on pin 3. So let's do that, positive there, negative there. And again, we're getting a reading of 739 now, 739, hopefully you can see that on the meter. So we're going to write that down, 739. 739. So now we know this is N as well, because pin 3 was negative, we got a reading, pin 1 was positive. So we've got positive, negative, negative. So now we've got here, we know that the base must be the only one, so the only one is P, and the other 2 are negative, so the base is the one with just 1. As you remember, PNP, the N is the base, and NPN, P is the base, so we've got NPN, so we know this is the base there, so that's that. It may be a bit awkward, like I say, depending what you've got around the circuit, but going by this, we just go back to them 2 readings. Oh, we've got them here, 735, 739. We're probably looking at that the base is here, pin 1 base, and I'm going to go over this again just to verify it. And we've got the N here, pin 2, which was 735, and pin 3 739. We know IR normally means emitter, so we're going to put E here and we're going to put collector there. So we think this is what it is. We've got base, collector and emitter on this particular transistor, and it's giving us the 2 readings. So I'm just going to go over that again just to clarify this. I'm just going to do them again, so hopefully you can understand what I'm trying to say here. So we're going to do our readings as we normally would. Positive on pin 1, negative on pin 2, and straight away it's giving us a reading 735. We wrote that down, and we know we had this on positive, we had it on pin 1, so we know pin 1 is positive. We had this on pin 2, which is black, which is negative, so we know that's negative. So we write them down, and now we're going to do the next reading, which is pin 1 is positive, pin 3 negative, and we put it on there, and we're getting 739, so we wrote that down. So we know that pin 3 now is negative. Before that we didn't know. That could quite easily have been positive, pin 3, because it could have been a PNP. But as we put this on here, and this on 1 and this on 3, positive on 1, negative on 3, we know that now this is a NPN. So always start off with so if you had a P, if you had 2 P's, start off with P, because you've got more P's, so it's PNP. If you've got 2 N's, start off with N. So now I know it's NPN. So that's what the transistor is. We know the one with just 1. So 1 positive means the base is positive. If we had 1 negative and 2 positives, we would know that the base would be negative. It's just the 1. Okay, so hopefully you've got that. So, but anyway, we're going to carry on testing now just to make sure this is okay. We're going to put this on pin 2 now, positive on pin 2, and this on pin 1. So it's going to be, I'll swap these leads around, it won't be too awkward with it. Positive on pin 2, this on pin 1. We're getting no reading there, so we can put a nice line through that as a no reading. We're going to do the same again, positive on pin 2 and the negative on pin 3. So hopefully you can see me do that. It just flashed a little bit there, but it's like I say, due to components in the circuit there. And oops, it slipped off my thing, but no reading there, so that's no reading. So put a line through that. Now we're going to do positive on pin 3, so let's just get these twiddled around a bit. Positive on pin 3, negative on pin 1, so we're going to do that without shorting anything out. And we've got no reading there. I'm not going to mark it down because while I've got it here, I'm going to do the other one as well. Positive on pin 3 and negative on pin 2. And we're getting no reading there as well. Hopefully you can see that. No reading of both of them, so we can put our little line through that, and we could say that we've just got the 2 readings. None of them are short circuit. Nothing's gone short circuit. Nothing's gone open circuit because we'll only get 1 reading. Nothing's gone short circuit. Could be, in this case, it'd be less than 700. So we know this transistor's fine. It's working, but it doesn't always mean it's working as it should, because, like I say, it could be a little bit intermittent. It could have a little bit of noise. It could be a noisy transistor a little bit. So you're not going to find that out, but you're going to find out that it is working. So this is for testing really that transistors are working and not blown. Not gone short circuit or not gone open circuit. Okay, just going to round the video off now. We've just shown you one other meter saying, just to show you that you're not always going to get exactly the same reading. It's going to be slightly different on your meter, depending on how it's made up inside, it's done inside, I should imagine, and maybe the battery life on your meter as well. You may get slightly different readings, but you kind of look at these kind of figures, ballpark kind of, you may go down to 600s, something like that kind of ballpark figure. I would have said, just to give an interest, this isn't miles out, this is very similar, but it is different. So I'm just going to show you, I'm not going to show you 2 readings because we know the 2 readings here that's going to read is pins 1, which is positive as we know, and pin 2. So if I just stick that on the meter there, we're getting a reading of 731, hopefully you can see that, where on the other meter was getting 735. And if we go to pin 1 and pin 3 with this meter, we're getting a reading of 734, 733 actually, instead of 739. So you're getting slightly different readings, that's all. I'm just saying, just to let you know, you're probably going to know anyway, but the meters can give slightly different readings, not always going to be precise. Okay, a long video there. Hopefully you've got something out of that. Maybe if you don't quite understand it, that you may want to rewind some of it and maybe get a transistor yourself and a meter yourself, a digital meter, don't forget. I will do one maybe later on an analog meter, but this particular episode or video is all about the digital meter. And don't forget to have it on ohms. Sorry, not to have it on ohms or anything else. You must have it on the diode setting of your meter, on the diode setting. So there you go. And don't forget, make sure you've got the common or the negative in the black and the positive or red to red. Make sure you get them the right way round as well to start off with. Okay, until the next video, I'll say thanks for watching, and I'll see you all soon.